So hello guys, how are you? I hope you are doing well. Hi, this is Ajay and we are in the series of Human Eye and Colorful World. Okay, uh, so this is the lecture number 4 in that series. So in this lecture we are going to solve two numericals or based on the eyes. Okay, and these will be myopia and hypermetropia questions. Okay, the first question is that an adult can see the object placed at a distance of 2.5 meter in front of him, but object far than this distance are not visible to him clearly. Then name the defect of the vision which he has. Give the correction of this defect. What will be the power of the suitable lens? Means a man can see an object which is at 25 meters, yes, 2.5 meter up to. After that 2.5 meter, he is not able to see anything. Means which defect he has? I think he has a defect of near defect. I mean short-sightedness defect. Okay, it means let's solve this question number. Solve question number one. What in the question is given is a guy can see up to 2.5 meters. Up to 2.5 meter he can see. After this 2.5 meter, there is nothing is visible here. Okay, if he goes here, not visible. Here, not visible. It is non-visible region. Non-visible region. Okay, here nothing is visible. This is visible region, right? Visible region, right? Okay, this is the visible region, right? Right, guys. It means up to 2.5 meter he can see the object. After this, he cannot see the object. Okay, means up to 2.5 meters, the image is formed on the retina, and he is getting a sharp image. After this, he is not getting a sharp image. So what we will do? See, let's see how the defect is. So for this object, the object is 2.5 meter. The rays will go like this, and they will form the image at the retina like this. But when the lights are coming from the infinity, okay, then they has to pass from this line. Okay, they has to pass from this line. So image will be formed here. Like this line is going like this, and this infinity line is going like this, and the image will be formed here. So he is not able to see the image which is coming from the far. Okay, so how we will correct this? We will correct with the lens. Which lens we will use here? The concave lens. Whenever the defect is myopia, so we will use the concave lens, right? So we use concave lens. See how it will help him. So let's say, so actually what we are going to do here, see, if somehow any object is here at infinity, okay, any object is there at infinity, he wants to see this image. Okay, this adult, he wants to see this image. To see that image particularly, if somehow we could manage to get the image of this object at this point, if somehow we could manage to get the image of this object at this point, then clearly he can see the object. So how we can form an image of an object which is kept at infinity to this point? How we can keep that? By using a lens, that is concave lens. Let's see how we can do that. See, let us say this is eye of human, and if we keep the lens like this, okay, so some object is like here, object is here, object is at infinity here. Okay, when the object is at infinity, somehow if we manage to get the image at 2.5 meter from here, then this image will behave like an object for this guy. Okay, this will be the image of the object, okay, this image now, let's say this is the image I1. So I1 will behave like object for the guy, right? For the eye, we can say for the eye. So okay, so now this image is behaving like an object for this guy, and this object is at 2.5 meter, and this we know that if any object is there at 2.5, he can see clearly. So it means from here we will see this is the image distance from the lens. So we will say minus. Why? Because we know that if it is the optic center, if we go here, the distances will be negative. If we go here, distances will be positive, right? Okay. So if we are going at this side, so it will be minus 2.5 meter. And where is the object kept? Object is kept at minus infinity. So object is kept at minus infinity here, and we have to get the image at minus 2.5 meter. If the object is kept at infinity, this image will act as an object for this eye, and this eye we can see clearly as it is a 2.5 meter from here. So we can use the formula for this one. This is the V is how much? V is minus 2.5 meters, and U is minus infinity. So focus we have to find. Okay, and which lens we will use here? We will use concave lens. So this is the answer of this one. Suitable lens. Suitable lens is what? This is the concave lens, right? Because it is short-sightedness. Concave lens we will use here. Okay, the focus we can find it out from here. So 1 upon f is equal to 1 upon v minus 1 upon u. This is the lens formula, right? So 1 upon f is equal to 1 upon v is how much, guys? Minus 2.5. It is minus 2.5, and plus 1 upon minus 1 upon minus infinity. And we know that 1 upon infinity is what? 1 upon infinity is equal to 0. We know that already. So it will become 0. So 1 upon f is equal to 1 upon minus 2.5. So it implies that f is equal to focal length is equal to minus 2.5 meters, right? Okay, so this is the focal length of the concave lens, which we will use for correction. Correction we can do by concave lens. Okay, so what will be the power of the concave lens? The power will be 1 upon f. So it is minus 1 upon 2.5. So it will be how much, guys? So it will be minus 10 by 20. So it is 2 by 5. So it is minus 0.4, right? 0.4 diopter. So power is 0.4 diopter. That will be minus. Remember, guys, the power of concave lens is always negative. Remember? Okay. I hope you understood this question. Okay. So let's solve the next question. So let's solve this question. Question number 2. Question number 2 is, an adult face problem in reading a book, but when he keep book far at 50 centimeters from him, it become easy to read the books. Name which defect he has. Give its correction and lens nature. What should be the power of the lens? It means what defect he has. I think it is hypermetropia. Why? Because he is not able to see the near images. It means farsightedness. Okay, it means it is a farsightedness. Okay, so he is saying that if we keep object at a 50 centimeter, he can see. Okay, and what is the near distance for a normal eyes? Near distance is 25 centimeter. We know that already. Okay, 25 centimeters. Okay, it means saying that when a object is kept at 25 centimeter, he is not able to see the image. Means he is getting the image like this. Is getting the image somewhere here like this. Okay, so image is formed behind the retina because he has a farsightedness or hypermetropia, right? Okay, so and if he has an image here at some 50 centimeter from here, 50 centimeter from here, he can see the image. How lines will go? Lines will go like this, okay, and they go to the focus, okay. So they will go to the focus like this, and he can see the image clearly, okay. You can see the image clearly if it is at 50 centimeters, right? So how we can just improve this one? Just use the convex lens, okay. Let's use the convex lens here. This is the eyes. Let's use convex lens. It means, suppose he keeps a book at 25 centimeter, where he can see the image. He can see at 50 centimeter. Okay. So what we will do? Actually, we will do that. We'll keep the object at 25 centimeter only, but image should form at the 50 centimeter, so that he will, this eye will feel that object is as 50 centimeter, and what will happen? He can judge. He can read now, because he can read up to 50 centimeters. Okay, if somehow we will be able to form the image at 50 centimeter, right? If we keep an object at 25 centimeter, if we are able to form an image at a 50 centimeter, then we can see the image, right? So let's do this. So here, let's keep a convex lens here like this. So here object is at 50 centimeter, okay, and the image should form at 50 centimeter. So this length is how much, guys? This length is 25 centimeters minus, why? Because we are going at this side. So, and the image is image is formed at minus 50 centimeter. So now he will feel that image is formed at 50 centimeter, and he can see the image very clearly, right? Okay. So guys, now we will use the formula 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon f is equal to 1 upon v is how much? Minus 25 minus 1 upon, it is object height, image is minus 50, and the u is here v is equal to minus 50 centimeter, u is equal to minus 25 centimeters, right? So minus 1 upon minus 25, right? So 1 upon f is equal to 1 upon minus 50 plus 1 upon 25. So LCM will be, I think, 50. So 1 minus 1 plus 2, 1 upon f. So f is equal to 50 centimeters. 50 centimeters. So the focus is positive, that is 50 centimeter, right? Okay, guys. So the focus we get at 50 centimeters, right? Okay. So which lens we used? We used convex lens. Okay. Okay. What will be the power? Power is equal to 1 upon f. So power is equal to 1 by 50. So it is how much? 0.2, right? 0.02. Yes, it will be 50, right? So it will be 0.2. 0.2 power is equal to 0.02 diopter. Okay. So guys, not this one. This will be 1 upon. So it is in centimeters, right? So we have to convert it into meters. So 100 by 50 we write. 100 by 50. So P equal to 2 diopter. Right? So power is equal to 2 diopter. Okay. So let's finish this lecture here only, guys. So next in the next series, in the next lecture, we will be discussing the prism, how the light will get deflected by the prism, what will be the waveguide, that we will be seeing. Where is the red color, where is the violet color, that we will be seeing in the next lecture. So keep smiling, keep studying. Okay, bye, thank you.